Hi, this is Ms. Park, and today's video is called the cosine law. The cosine law is another tool that we'll use to find missing sides and angles in a non-right angle triangle. Okay, and the reason we need the cosine law is because we've already learned the sine law, but sometimes we can't use the sine law because we don't have the right information. So if you look here at case 1, notice that there's a side and there's another side and there's an angle in between. The sine law had these fractions that looked like this, right? This was in the sine law. And so we had to be given an angle and a side directly across from it. And if you see in case 1, we have a side little s, but we don't have angle s. And we have a side little r, but we don't have angle r. But we have angle q, but we don't have side little q. So we don't have a pair of a side and an angle given to us, so we can't use the sine law. Look at case 2. There are no angles given. So for sure we don't have a pair of an angle and a side across from it because we don't have any angles. So in these two cases, we can't use the sine law. So the cosine law is just another formula that looks like this. It looks pretty complicated, but really we're just going to put numbers into the formula and use our calculator. So if we have a triangle ABC, and look how we've labeled the sides little a, little b, little c, then if we're solving for, let's say, side little c, we'll use this formula. So I'm going to write solving for a side length. And it says that c squared equals little a squared plus little b squared. So that's kind of looking like Pythagorean theorem. But minus 2 times little a times little b cos of big C, where big C is the angle across from it. Okay, if we're solving for an angle, we use this formula. So this formula is exactly the same as the one above, but it's been rearranged so that it starts with an angle and not the side. So notice that on the left, it starts with a big C, which was an angle. So if we want a side, we'll start with, we'll take the first one, which starts with a little letter for side. And then I'm just going to write here angle. And if we want an angle, we'll use the second version of the formula, which starts with an angle. Okay, so I'm just going to put here side, and this big C, angle. So you can choose the version that you need depending on what you're solving for. Let's do an example. Okay, solve for a side length using the cosine law. So let's write. So this is little q. This is little s and this is little r. We have the side length little s and little r, so let's find little q. Okay, so because I'm finding a side length, I'm going to use the version of the formula that starts with a side length. It starts with a small letter, except that the one I'm trying to find is q, not c. So I'm going to replace the c squared with little q squared. And I will replace the cosine of big C with cosine of big Q. So these two have to match. The one you start with and the one you end with have to match. They're both Q. And now all the other letters go in between. So this will be S squared plus R squared minus 2SR cos Q. Now the numbers will go into the calculator. So Q squared is equal to, so S squared is 28 squared plus 16 squared minus 2 times 28 times 16 cosine of 89 degrees. This entire statement, if you're using a calculator, can go in all at once. Remember that if you're using a phone, there's a little bit of an order issue. You can still do it, but you just have to be careful with the order. So I'm going to put this entire statement into my calculator all at one time. And I get 1024.36. So approximately 1024.36. And just remember, if little q can't be 1024, it's not going to be 1,000. That doesn't make sense in this triangle. Remember that that's q squared. So q is going to be the square root of this number. So the square root of this number is 32. So q is approximately 32. And 32 looks like it's reasonable for this triangle. so centimeters. Okay, let's do an example where we have to solve for an angle. Okay, if you need more time for this question, just pause the video and catch up, and then move along to here with the angle. Okay, so solve for an angle using the cosine law. So let's solve for angle R. Okay, so solve for angle R. Okay, so this is the one we want. So if that's the one we want, then notice how we're using the flavor of the formula that starts with the angle, not with the side. Okay, and so I'll put cosine, and we want angle R, so we'll start with R. Okay, now in the formula, where does the R show up again on the right side? So look here, you have the cosine C, and the C squared is there. So that means it's going to be the other two letters. So this is S, and this is Q, and this is R. So it's going to be the other two letters, so S squared plus Q squared, then minus R squared, over 2 times S times Q. So cosine of angle R is, put all the numbers in, 24 squared plus 18 squared minus 26 squared, all over 2 times 24 times 18. So cosine of R equals, actually it's not even approximately, it's just equals. Cosine of R equals, I'll just leave it like that. And then we can figure out the numerator. So 24 squared plus 18 squared minus 26 squared. That is 224 divided by 2 times 24 times 18. 864. Okay, so once again, we have an angle that we don't know and we want to find out. We know the cosine of it, but we don't know the angle. So when we know the cosine and we don't know the angle, then to get the angle out of there, we have to undo the cosine. Undo the cosine means use the cosine inverse button on your calculator. So you take the value of the cosine and then you inverse cosine so that you can get the angle back. Okay, so in my calculator, I'm going to go inverse cos, so second function or shift or whatever your calculator does, and then open a bracket and go 224 divided by 864, close the bracket, and I get approximately 75. Okay, 75, and this is solving for the angle, so our units is not meters, it's degrees. Okay, so there you have an example of cosine law with solving for side length and solving for an angle. Okay, so please practice cosine law. Thank you.